This example is going to walk us through the meaning of the intermediate value theorem. Before we talk about this, let's review what the theorem states. It states that if we have a continuous function on a closed interval, a to b, so that a to b just tells us where we're going to be continuous on. We've got a sitting right there, we've got b sitting right here, and we have some sort of continuous function. Who knows what it does, but it's continuous. Then the conclusion is for any y value in between the outputs of the function f of a and f of b, so let's figure out where those are. Right, if this is my y-axis, then here's f of a, here's f of b. So for any y value sitting over here, there's going to be an x value in between a and b. So there's going to be some x value here such that if I map the x value underneath my function, I get that y value. Right, so you could pick this y value, and there's going to be some x value, this one, that gives you that y value. In fact, there might be several. Right? It doesn't say that there exists only one. It just says that there exists at least one. There's some x value inside the interval a to b that maps you to every single y value in between f of a and f of b. So this is a really important theorem. It's used a lot, and one of its heaviest uses, one of its most useful uses, is showing zeros for functions. So let's think about this example here. We have a discontinuous function. So this is the intermediate value theorem will not apply to this. We'll see why it breaks the intermediate value theorem. And then we'll have a continuous function in which, of course, the intermediate value theorem has to apply. So think about this discontinuous function. Over here on the negatives, the function returns a value of -1. Over here on the positives, the function can returns a value of +1. So if the function was continuous, then it would have to hit all of these y values in between. But here we see that it's discontinuous. In fact, it's a jump discontinuity. So the intermediate value theorem does not apply. That's why it's allowed to jump from -1 up to +1 without passing through 0. It's a discontinuous function. So the intermediate value theorem does not apply here. Here, though, the hypothesis of the intermediate value theorem is met. We have a continuous function on a closed interval from -5 to +5. So that means all of these y values have some sort of x value that gets mapped to the y value. For instance, if I look at 0, the x value of 0 gets mapped to the value of 0. So over here, we were allowed to jump from negatives to positives using a discontinuity. Over here, we were a continuous function, so the only way that we could jump from negatives to positives was by passing through 0, by giving ourselves a 0 of our function.